All righty, welcome everybody. Day 2 of week 1. We got lots of fun stuff ahead of us. We are learning today more of our vanilla JavaScript, specifically things about objects and hierarchies and parents and children and callbacks and maps and filters. And oh my, this is going to be fun. So let's see if I can cut this a little bit less time, but covering just as much good material. I want you to know that you guys can still reach out to me in the chat and pipe up if something's not making sense to you, because the objective here is that everybody learns it. And if you've got questions, it's not unusual to have someone else that has the same question. So let's go ahead and jump into this. I just want to remind you, I'm posting the assignments of when their due dates are in Mattermost, and if you have any desire to go and see the old videos, you can see those in the platform under the lectures section. You can also reach out to me or a TA in Mattermost. I'm around tomorrow. I wish I had 4-day weeks, but just like everybody else, I get to work more than the 40 just to make sure that everything gets done right. So you guys just reach out to me and ask. I'm here to help you, because my biggest thing is making sure that each of you understands and learns and grows, because that's where I get my bucket filled, when you guys are clicking and this makes sense, I'm loving it. So don't hesitate to ask. If there's any other things that you have questions about, even not specifically about code, but just the program or anything, reach out to me. I'm happy to help out with you there as well. We're going to dive right into object-oriented programming today. I want to ask you, first of all, what is an object? We've talked about the DOM, the document object model and stuff. We've talked about objects, but let's understand, what is an object?
It's some sort of data structure that holds information. For if you had a const person, and I would say name Antonio, hometown New York, age and everything associated with that. And then if you had a nest, if something was nested, I think it's called a method inside, if I'm not mistaken.
So yeah, I mean, you're touching on the right things here. We make an object in programming that uses data to represent something that's real, right? I mean, if you go and look up object-oriented stuff and you're trying to look for tutorials, I guarantee you there's going to be a million things out there that talk about cars and food and classrooms, and because they're things that everybody understands. They give you that that familiar piece to come in with coding. So anyone else want to add anything to what Antonio said about those?
It's like a blueprint of a class, or kind of a logical code of a file tied together so that it can be reusable.
That's actually a really good way of saying it. It's there are objects that can be created from classes, and we can make these objects look like each other, right? The picture that I've got on my screen right now is of a classroom, right? We all have just scary memories of being in that classroom, sitting in front of the chalkboard. You know, it's one of those feelings that you kind of get here as well. You're like, oh my gosh, they're going to throw a whole bunch of new stuff at me, and I got to somehow retain it in my brain. Luckily for us, everything we do is open book. If you're good at Google Foo, you're going to do awesome. But let's look at this picture and think about, what are some of the objects in this picture? We aren't going to go through all of them, but give me some of the objects you see here.
Books, desk.
Perfect.
Teacher and number of students.
A teacher and students. So a number of students might be just a single piece of information, but it could be in reference to something we would put into a classroom class. That's right, a classroom object. What else?
Decoration objects like the truck, the cactus, the flowers, the grad cap.
Awesome. That's right. Everything in here, everything that we can see that's tangible is an object.
Mm-hmm.
And every single one of those things we could talk about in more detail, right? So if I said, okay, what about a chair? What types of things make up a chair?
The material of the chair, the components of each material, the part numbers, and the components that attach the wood, so like these screws. And if you want to get crazy, adhesives that are used upon the chair as well.
Could you create something in terms of like an object that said books, and then within that, would it be considered a method if you had math books, science books, English books? Within that, would that be considered a method of books category within an object?
You know, you're actually hitting on one of the more advanced topics that we're going to be getting into called hierarchy.
Okay, sorry.
Because no, it's perfectly good. I love the way that you're thinking in depth and trying to break things down into smaller pieces, because that's quite literally in programming, we break things down and we take all the pieces into their smallest components, and then we build things. We put all the pieces together, right? And so like Will just said in the chat here, we have attributes and we have methods. Every one of these objects has got things that comprise all the pieces to it, right? We have the pieces that are going to tell us specifically about this one chair. This one's made out of wood. That one's made out of metal. This one has 3 legs. That one has 6, you know? And each one of these things, they're still technically all chairs, but they all have unique pieces and parts to them. And, you know, if you looked at all 6 of these desks, I guarantee they're all different, because somebody has scratched their initials on one of them, and another person spilled their Kool-Aid and the stain is still there. And, you know, I mean, there's going to be unique things about them, but there's similarities about all of them. They all came out of the same factory, intended to be identical, at least to start, right?
So you're essentially talking about setting up a structure that will kind of keep track of core attributes that can be passed along a similar object. So in this case, like all the desks, you have like a leg attribute, like a surface finish attribute, and like you kind of can go from there and grab all the similar objects, and then you can essentially funnel every desk through that. You call it like a class manager, if you will, or you could, kind of like allow the data to go in clean and then store it. Correct.
So yeah, but you're looking at instances of classes, and so let's go ahead and excuse me. Let's take this idea of working with code and look at the 4 different ways that we can look at it, and also try to understand the 4 things that object-oriented programming is trying to accomplish. So let's go ahead and look at this. Procedural language. This is what we've already been working with, right? In JavaScript, we create a variable and we assign a value to it. And then we create another variable and assign a value. And then I can take this function and I can pass in a couple of variables and have it print something out. And I use that function and I pass in my variables and it prints out whatever I'm supposed to have, right? This is nothing new. You guys have been working with this already. And I take my variable student name and my student age and I pass them in here. and they come into the function, and the name I'll use in a print statement, but the age, I say, okay, if the age is less than 11, then they're in elementary school. If their age is less than 15, which means they have to be at least 11 years old, because I passed this if. So this is saying basically, are they between 11 and 14? Are they less than 15 years old? If they are, then I'm going to console log their name is in middle school. And last but not least, if this is a student and they are 15 or older, then I'm going to just throw them in the else here and print out that they're in high school. Nothing crazy about this, right? So then we take it to the next step. We can deal with objects. We can consolidate everything together into a single package. And this packaging is actually referred to as encapsulation. We are, if you think of like a capsule for medicine, right? It's two little halves that they stick stuff into, and then they seal it up, and everything is encapsulated. It's in the capsule. And so all we did is we took these curly brackets, and the curly brackets are JavaScript's way of saying this is an object, and I've added in a key, which is a variable, and its value. And then I added another key, and its value. Now these ones, since they're holding data, they're called attributes. Some languages will refer to them as properties. An attribute is just going to hold something, like a chair object would have a number of legs, 4. A desk would have number of legs, 4. Then if I have it doing something, okay, it's taking an action, then that becomes a function, but that function is still assigned, just like we were discussing in the office hour, a variable, or in this case, the object key, can be assigned a function. And so the value for this key is this entire function. And it's doing actions. Now, there's some slight discrepancies, but in a sense, this is a method inside the object. And to use these things, I go ahead and I've created one object, and I called it student1. I assigned that object as a value to student1. And then I created a second variable called student2, and I assigned it the object in between these curly brackets. This object has attributes and a method. Well, the nice thing is this being all encapsulated together, it kind of travels around as a package deal, right? Anytime I'm talking about student 2, there is no question. Student 2 is 16-year-old Sally. And student 1 is always going to be 8-year-old Billy. Okay? And so if I refer to student 1, I'm saying, Billy, run your method, get school level. And it comes up here and it says, okay, this, do you guys remember what this refers to?
This is the current working object.
Perfect. That's exactly right. This function is running specifically for this instance, this object instance is the word that they use is instance. It's this object. And so whenever we're dealing with this, you guys remember we were talking about scopes and how arrow functions allow this to refer up. This is a special keyword, and it's used to say this instance, this object. And so as a result, I mean, the nice thing is I can copy and paste this object and create as many students as I want. But that's manually creating things that they refer to as object literals. There's plenty of times you're going to create an object literal like this. And it's because, honestly, I don't need 16 of this object. I only need one, and I need to pass it around. And it's easier to pass one thing than 10. Package them all up, put them in one object. But
how would you create a new student 3 without copying the how would you go about programming that? I mean,
that's actually a great question, because that takes us to the next thing. The next thing is we can create a factory. A factory is a function, okay? This function here, it's called create student name, and it takes 2 parameters. Now, a factory, in order for it to give you what you're hoping for, you'll notice it's returning an object. So it hasn't assigned a name to this object, it just returns a full object, and it fills in using these parameters, the name and the age. And this function, it doesn't change from student to student, so that can stay right there too. All right.
So a factory is equivalent to the new statement for an object, for a class?
Yeah, pretty much. It's pretty much a new when we're dealing with classes. This is standard JavaScript here. We can create these factories because a factory is, if I wanted it to be a chair, I want the chairs to all come out the same. And maybe I'll put a different serial number on it, right? But otherwise, everything about that chair is, it's going to have 4 legs. I've tooled up my factory so that it's going to do the exact same thing over and over and over. So this factory here, you'll know that when you start looking at OOP, there are what's called design patterns. And one of those design patterns for creating in OOP is called a factory. A factory is designed to just stamp out things over and over. And if you've got, 1 million widgets that just need to change by a single number, well, don't copy and paste it a million times. Just create a factory and use it. And the way we use it is just like any other function. We call the function and we pass in the arguments to the function. And since we are returning an object, that object gets written into our variables. And so this whole object is just going to get placed right in there. And then we call it again, and sure enough, that whole thing comes down and it's put right here. So, I mean, we can now, without having to copy and paste, we can make this as much as we want.
Hey, Kevin.
Yeah.
Would you be able to, that would be considered a longhand function, right? Or would you be able to convert that using the curly braces and the parentheses outside, or with an if-else statement like that? I tried to experiment with that, but I didn't know really how to do that. It was a little advanced.
That's all you have to do.
Oh, okay. Okay.
I mean, you get rid of the keyword and you convert it into an arrow function, and that's the shorthand version of this. But go ahead.
I mean, for the create student, would you be able to introduce that with that intricate level inside of it? Like,
well,
the create student, would you be able to minimize that by using, was that considered a longhand in general? Could you like minimize this whole thing? Or is that?
Well, there are several ways that I could minimize this. using like ternary operators and everything. If I wanted to, I could change this one here. I'm just going to go for it here.
Mhm.
So I could do this and turn this into that. And then if I wanted to, I'm just going to duplicate this so I don't kill it and ruin myself here. But I can do this. Oops.
Mhm.
And then I can do my colon.
Mhm.
And then I make another ternary. And that one gets indented here. And then I can get rid of these. And then I got to get rid of the extra semicolons,
Except for the last one.
except for the last one. So what I've done is I've done nested if then else ternary operators. So this is about as slimmed down as you can get it.
Okay.
And so, yeah, this is kind of crazy right here. And I think, if I'm not mistaken, I need to actually get rid of an extra curly. So, yeah, that would be using ternaries and all arrows.
Okay.
Why do you need the this in this case?
Well, because we're still referring back to this object.
Mm-hmm.
And so I have to tell it which object name I'm referring to. So once this object gets assigned to the student,
Yes.
then at this point it's, converting to arrow functions, I almost wonder if, no, that would be all right. So, because we never had function as a keyword here. This is referring to this object,
Yes.
because it doesn't have, inside this function, we don't have a variable called name. And so it requires us to tell it, where am I going to find that? And so
Okay.
you got me curious, and curiosity killed the cat, and it kills me at times too. So I'm going to do this. So let's see here. I need to go into my OOP folder, and we'll go node 3. All right. So without the keyword function here, it does recognize that the name variable here actually passes through. But I think I'd still feel safer for other developers to read my code if I left the this in there.
So it basically, like, if you want it to be more, not foolproof, that's the wrong word, but essentially it's safer to just include this in this case.
Yeah, but now you'll here's the interesting thing. I put this back in because of my arrow functions. It's put me in the wrong place. It's pointing to undefined now. Converting it to arrows. This is one of those keywords that, honestly, I don't hesitate to say I would make a mistake and it doesn't turn out right, and I go back and I change it in my code and use it that way. So, I mean,
that's so
because
bizarre.
we went to arrows, because the arrow function changes the scope that we're looking at.
Yeah.
Everything floats to the top, but that's just a small portion of hoisting, is that floating to the top. it truly affects this keyword, which apparently is taking us, in this case, since we didn't have function,
Mhm.
it allowed it at this level. More than likely, we are looking at the global object, and it's not defined inside of that function to get a name out of the global object. So yeah, that one's kind of crazy. Uh-oh. Oh, garbage. No, 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 no. That is not happening.